Hi there guys, today we're going to be explaining our orthographic projection. We'll call it the first angle orthographic projection, and we're going to explain why the front view, right side view and top view is where it is. You'll note that the right side view is actually on the left hand side of this planes model, if you want to call it, which is a 2D shape. It's a flat piece of paper, and in a moment's time we're going to be folding this piece of paper so that it represents a 3D model. We also need to remember that our axes are also labeled X, Y and X1, Y1. Right. In front of us we have that 3D model, our 3D planes model, and you'll be able to see that each one of these eyeballs will be able to see the necessary views that are projected onto each one of the vertical planes or horizontal planes. If I look from the right hand side, I'll be able to see the right side view. The right side view, which will be this surface over here, projected back onto this area over here. So theoretically, if I had to shine a torch from this eyeball view, I'll be able to cast a shadow onto the wall right behind it, this size. It just projects exactly what I see in this side, which is my right side view. This would also be seen or known as a right vertical plane. If I had to shine a torch from this eyeball's view, I'll be able to see this surface, yet I'll be able to cast this shadow on this vertical plane, which will then become the front view. This is the front view I will be drawing on the vertical plane. And then obviously if I'm going to be looking from the top and shining a torch down from the top, I'm going to be casting a shadow down onto my horizontal plane. And also this eyeball will be able to see this view, this surface at the top, which will be drawn directly below. Yet again we know, or take note, that our axes in this case will be X, Y, and X1, Y1. Okay? In a moment you'll see Y, Y1 will move. Right, I've just flipped the top view straight down so that I can see it as a flat surface. I'm going to just take it back a step. There we go. Please take note how this plane is actually folding flat. Alright. Please take note that the Y, or the Y1, is going to be moving down to the bottom over here. I've already labeled it here, and I've already labeled this one top view. There it goes. Right. My Y1 will now end up over here. My top view, which was over here on this plane, has now been folded down onto this vertical surface. Note X1, Y1. Now you can see why X1 and Y1 are opposites of one another. Yet X is not opposite Y just yet. What I've just done is I've taken that right side view and I've flipped it over so that I have it corresponding to the actual vertical plane, which is a nice flat surface. And let's just take it back a step. Please take note how this surface, or this right side view, is projected back along this arrow over here. My X will now move along this arrow to this position over here. There we have it. Okay, so theoretically we've taken a 3D object and we've unfolded the actual planes and we've made it a 2D object, or a 2D representation of the object, and that is exactly how this orthographic projection will be best explained. I hope you guys have enjoyed this, and we will have a couple more videos after this. Please stay tuned. Please don't forget that you will need to subscribe to stay up to date with any current videos.